So we're going to start out by talking about the fifth and final category of factory method operators we're going to cover related to the Flux class in Project Reactor. And this time we're going to talk about the two-parameter version of create. We talked about the one-parameter version of create before. Now we're going to talk about the two-parameter version. This two-parameter version creates a flux that can emit multiple elements, either synchronously or asynchronously. And it also has a parameter that can be used to designate the overflow strategy. The first parameter, which is a consumer to a flux sink called an emitter, will emit any number, 0 to infinity, of next signals, followed by 0 or 1 error or on complete signals. And this flux sink is the means by which that is done. As with the one-parameter version of create, this supports more dynamic use cases than the very simple Flux factory method operators like flux, from iterable, from, and so on and so forth. The second parameter is used to define the strategies for handling overflow. And there's a bunch of them. We're going to talk about them. We've talked about them before. Briefly, buffers everything, drops an incoming signal if the downstream can't receive it because it's busy doing something else. Error throws an exception. We'll talk about the exception. It's actually not the illegal state exception. That's a mistake in the documentation. Ignores downstream back pressure request, which is a mysterious strategy. And then latest says you only take the latest element if you don't have enough downstream to be able to handle it. Back pressure is a very strange choice of the name for this parameter because it's not really back pressure. It's really the overflow strategy. There is no back pressure, really. So back pressure would have to be done through other means. I don't know why they called it back pressure. They should have called it overflow strategy. And this returns a flux that emits all the elements that are generated by the flux sink. Here's a very simple example. We'll, of course, take a look at this example in more detail when we get to this case study. We're going to call a factory method called makeEmitter, which is going to emit a stream of random big fraction objects in one fell swoop. It'll emit it without being concerned with back pressure, which is why the back pressure name is such an odd name here. We're going to give it the error overflow strategy, which says if you can't keep up, throw the overflow exception. And then we're going to block here using a blocking subscriber, and that will start off all the asynchronous processing. We'll take a look at some examples of how this works when we get a little further along. The elements that are emitted by the emitter can be generated from one or more threads. And I always get a kick out of this marble diagram. It looks like a roller coaster. I was down in Universal Studios over the break and went on some of the roller coasters. And this looks like some of the roller coasters there, which are very, very high G-force inducing. But this just means that you can have multiple threads going on here and generating the events. There's a create method on RxJava's flowable class, which is very similar. The main difference is that the data types that are passed are slightly different. So rather than passing a consumer to a flux sink, they have something called a flowable on-subscribe. Why they did this, I don't know, but they like that design better somehow. Java Streams has a generate method that is similar in the sense that it generates an infinite sequence of things. However, it doesn't need to handle back pressure. And that's because Java Streams works differently. With Java Streams, when you reach the terminal operation, it starts to pull the events through from the data source, whereas with RxJava and Project Reactor, it pushes the events through. So you have to be much more concerned with the issues of producers or publishers generating data faster than the subscribers can keep up. So we have a similar concept, but we don't need to worry about back pressure with streams. That would probably make a good question for a quiz if we haven't done that one already. So that's the end of the overview of the two-parameter version of create. We'll take a look and see how this gets used in conjunction with the overflow strategies here shortly.